Hi everyone and welcome back to Lyfey Technologies YouTube channel. I hope you're doing well and thank you so much for watching this episode. So this is another session of our Huawei Lab simulation series. Remember, in this series we demonstrate to you how to configure, troubleshoot and implement different networking technologies or different networking protocols on Huawei routing devices. So if you are learning how to configure different protocols or you want to know how to troubleshoot different protocols on Huawei routing and switching devices, kindly check out this series on our channel. So in this session, we are focusing on how to implement ISIS fast reroute on Huawei routing devices. So we'll be explaining to you what ISIS fast reroute is and why we need it on a network. So when you are deploying a network, you need to ensure that the network is resilient enough. You need to ensure that the network is robust enough to handle any challenges that are happening in the network. These challenges could be a link failure, it could be a node failure. So what happens when there is a node failure? Will the network be down the whole day? What happens when there is a link failure? How long does it take for the traffic to switch to the redundant path or the backup path? So you need to ensure that it's very fast. You need to ensure that this switchover is seamless and we only have milliseconds to restore the services. So these are things that you need to consider when you are deploying a network, especially when it's carrying some sensitive services like VoIP or video, real-time videos. You need to ensure that whenever there is a node failure, whenever there is a link failure, the traffic should be able to adapt quickly. The traffic should be able to switch over to the backup path quickly to ensure that we have minimal disturbance, we have minimal downtime for the services. So, you know that many times we have protocols deployed on a network. We could be having an IGP like ISIS for this example. You have ISIS deployed on your network. It could be a small network, it could be a medium-sized network, it could be a service provider network. So when you have this protocol deployed, this protocol, they normally take time to converge. So whenever there is an issue on the network, a protocol like ISIS will take some time to converge. It has to go through some processes. It has to go through some stages for it to be fully converged, and then the traffic will be able to switch from the primary path to the backup path. So for example, in ISIS protocol, imagine that you have a link failure or there is a node failure. So whenever this happens, we have some stages. Let me just add a text box. So first, when there is a fault in the network, ISIS will be able to detect the fault. So of course, for this case, you can be having, ISIS will take more time. So you could be deploying protocols like BFD to ensure that the fault is detected quickly. And then once it has detected that there is a fault, this fault could be a link failure. The link has gone down, the fiber cut has happened in the network. There is a power issue somewhere. So the node is not reachable, it's isolated. So there is a node failure, kind of a fault in the network. So once we are able to detect that fault, we need to send some LSP. So we need to update the LSPs. So ISIS will send some packets and update the LSPs. And once the LSPs are updated, we also need to flood LSPs to the neighbors. So we've updated our LSP, we now need to flood them and tell neighbors there is a fault that has occurred in the network. So we need to flood the LSPs. And once we've updated the LSPs, flooded the LSPs, we need to calculate the routes. So we need to do route calculation. So we have our LSDB synchronized. We need to recalculate the routes and ensure that now we have the updated routes. And once we have the routes calculated, we still need to install the routes in the FIB, the forwarding information base. So this one will actually take some time. And during that time, the services are down. For a small network, it may not take a longer time, but for a big network with thousands of routers or 10,000s of routers, this will really take time for the network to converge. So you need to detect the fault, you need to update the LSPs, you need to flood the LSPs to the neighbors. they need to now calculate the routes, recalculate the routes, and once now they have calculated the routes, they need to install these routes in the forwarding information base, and then we can now resume traffic forwarding from point A to point B. So you see that during this time, we are having packet loss, we are having services down, and the users are complaining because the calls are not going through, the video is buffering, and this one will normally take some time. So we are trying to look for ways in which we can speed up this process, because you can see that on this network, R1, R4, R5, R3, and R2, they are all connected. So from R1, if you are going towards R3, you can either use R4, R5, or you can use R2. And normally, when you have a protocol like ISIS just operating alone without fast reroute, ISIS will only have one route installed in the routing table. The backup route will not be available in the routing table. So it means that route has to be advertised to R1 for it to be able to switch the traffic towards the destination. So this one normally takes time, and that's why we need to adopt the fast reroute. So fast reroute, this is a mechanism that is used in IP/MPLS network, and the goal is to ensure that whenever there is an issue, whenever there is a fault in the network, we are able to quickly switch the traffic from the primary path to the available backup path and minimize on packet loss and service disruption. So we are able to quickly reroute the traffic without waiting for the full routing protocol convergence. So we won't wait ISIS protocol to detect the fault. Once the fault is detected, we should switch the traffic. We should not wait for it to update the LSPs, to flood the LSPs, to calculate the routes, and install the routes in the forwarding information base. So we are able to save on some time and ensure that services are restored quickly. The user may not even notice that some services are down. So it's kind of seamless, because it's now less than sub 50 milliseconds. So of course, faults in the network could be link failure, could be node failure. Again, all this could happen, and we need to protect the network to ensure that we have a resilient network, we have a robust network that is having minimal disruptions whenever there are faults detected on the network. So that's why we need to deploy the fast reroute to ensure that we are able to quickly switch or reroute traffic whenever there is an issue in the network. So this is what we'll be demonstrating to you, ISIS fast reroute. And this is the topology that we are using. You can see that we have R1, R2, R4, R5, R3 connected. So of course, based on the metric, we are not configuring any metric, and the default metric of ISIS is 10. So it means R1, if it were to access any node on R3, it will go from R1 to R2 to R3, because this is 10, this is 10, so the cost will be 20. But we have a backup path via R4, R5, which will be having a cost of 30 towards 3.3.3.3. So we'll be configuring the loopbacks, and then we need to test and verify that our fast reroute is working okay. We are able to have backup path installed on these routers towards some destinations. So for the configuration steps, again, very straightforward. We need to do interface configurations. We need to configure the host name. We need to assign IP address on the physical connections. We also need to assign IP address on the logical configuration, the loopback IPs. Once we've done that, we'll go ahead and implement ISIS on the routers, ensure that we have reachability, ensure that our LSDB has all the information, ensure that we have the routing information. We confirm that on R1, we only have one route installed in the ISIS routing table towards R3. And then we'll go ahead and implement ISIS fast reroute and confirm that we are having the backup route installed on R1 or all the router that we've implemented fast reroute. So the first step, we need to configure IP addresses on interfaces on all the routers. So this is the topology in ENSP. These are the interface connections connecting to different routers, and the IP addresses, the point-to-point IP address have been assigned. So we'll go ahead and do the basic configurations. So starting with R1. So for R1, let me undo terminal monitor so that it's not printing so many log messages. And you can see these are the basic configuration that we need to do for IP address on interfaces. So we configure the sysname as usual. We've been doing this from session 1. Remember, we are now on episode 63 and we'll be reaching episode 100 very soon. So just a request that please subscribe to our channel and stay tuned in for more upcoming sessions. So you see that these are the interface parameters that we are configuring on R1. We are assigning the IP address as per the IP plan. So these are the loopback IP addresses that will be assigned on these different routers up to router R5. So I'll go ahead and do this configuration starting with R1. And then we need to do the configuration for R2. I will undo terminal monitor to stop the debug messages. We don't need them for now. Then I'll do R3. So we are just configuring the basic parameters. When I do these configurations, if you feel you are having, let me see, R2. We've configured R2. We should be on R3. If you feel there are some commands that you don't understand, because we've been doing these configurations many times, so some configurations I may not explain in details, but if you feel you have seen a new command or there are some commands that you don't understand what they are doing or why we are configuring them, always feel free to reach out through the comment section and we'll be glad to help you understand these commands. So on R3, undo terminal monitor. Then I'll do R4. So this is R4. Again, undo terminal monitor. Then we can do R5. Once we've completed the basic configuration for the interface IPs, of course, you can always run commands like display IP interface brief. You will see the IP addresses assigned on the different interfaces, both physical and the logical interface. You can also do ping for the point-to-point IPs. For example, I can decide to ping 10.10.10.2 just to verify that my point-to-point IPs are okay. Can also ping .5 to see that my point-to-point IPs towards the other router are okay. So once I've done this verification on all the routers, I can go ahead and do the second part of configuration. So this should be step 2, and step 2, we need to configure ISIS on all routers. So we configure ISIS on all routers. Let me see, actually this is still step 1, this should be step 2. Control Z, control copy. This is step 1. Step 2, this is where we need to configure ISIS on all routers. So we are using ISIS as our IGP to ensure that we have reachability. Again, the reason why we configure an IGP on a network is to ensure that we have reachability between different nodes. And then we can go ahead and implement other features like BGP, because once we have reachability, we can go ahead now and configure some other overlay protocols like BGP, we can do MPLS, and all the other protocols can now run on top of this network. So For ISIS, we are configuring ISIS process 20, very straightforward. We are configuring ISIS level 2. So remember, we have different levels, level 1, level 2, and level 1, 2. By default, it will be level 1, 2, but for the backbone network, we normally prefer to use level 2 so that the LSDBs can be exchanged between different routers without any challenge. And then we are configuring the network entity. So for the network entity, we are deriving it from the loopback IP. So again, we've already discussed how to derive this network entity. If you don't understand, you can check our previous episodes. And then we are configuring IS name to ensure that we are able to identify the adjacencies between different routers. And next, you need to enable ISIS on the interfaces just using one command, ISIS enable 20. So 20 is the ISIS process that we've configured. So let's go ahead and do these configurations. The network entity should be unique on all the routers. So I'll copy this for R1. And then for R2, we are doing the same. Configure ISIS, activate it on the interfaces. Then on R3, we do the same. Configure ISIS and activate it on the interfaces. On R4, we do the same. Then on R5, we also need to configure our IGP, which is ISIS. So of course, fast reroute is supported by many protocols, BGP or SPF and many other. They are all able to support fast reroute. So in the upcoming sessions, we can also demonstrate to you how to enable fast reroute for OSPF protocol on different vendors. Then on R5, we also need to activate ISIS. So once you've configured your IGP, we can go ahead and run these commands to verify that our ISIS peering sessions are up. So display ISIS peer. You see that we have two ISIS adjacencies on R1, R2, and R4, and that is expected. You can display ISIS route. So you see that these are the routes that we are getting, and our focus will be 3.3.3.3, which is having two next hops. So you can see that this is the routing table on this router. We can check LSDB, display ISIS LSDB. So you find that these are the details in our LSTP. These are the LSPs. You can display ISIS interface. These are the interfaces that we've activated ISIS. You can do the same on the other routers, display ISIS peer. So you expect to have two peering sessions on all the routers, display ISIS route. So you see that we are having the routing information. So let's check on R1, we should be able to ping the loopback IPs of the other routers. So 2.2.2 should be reachable, and then 3.3.3 should also be reachable, and 5.5, this is 4.4.4, should also be reachable, and 5.5. So these are some of the basic checks that you need to do when you are implementing a network. You don't wait until the last minute for you to test everything. No, you must verify step by step. So this is just the default ISIS. We haven't done any fast reroute configurations. So if I were to display ISIS route on this router and 3.3.3 and do verbose, you will see that we only have one next hop installed on this router. And the next hop is 20.20.20.1, which is via interface gig 000. But we know that when you look at the topology, we have multiple paths. We have an alternative path, which is the backup path via R4. So that's what we expect when we have fast reroute in place. But first, let's first shut down this interface. So I'll do a continuous ping from this router. I'll ping hyphen C, maybe 1,000, and then I ping 3.3.3.3. So that is a continuous ping that is running. I'll do a shut down the interface to simulate a fault on the network. So I'll go interface gig 0/0/0 and shut it down. So when you shut it down, if it's a bigger network, of course, you expect that it will take time for the services to switch. This is a very small network, so the convergence, the time may not be a big issue. But when you have a bigger network, it will take time for that route to be propagated across the different regions or across different routers in the network. So we may not be able to simulate that. But when I go back to the routing table and display ISIS route verbose, you see that actually I need to shut down the primary. Sorry for that. I shut down the secondary path. So I will undo shut down. Ensure that the link is up, display ISIS peer. So the peering session is up. We give it some time for the convergence to happen and the routes to be propagated correctly. So I'll go ahead and on R2, now I need to shut down the interface towards R3. So I'll do interface gig 0/0/1. On R1, our ping should be continuing. So on R2, I'll shut down the interface, then go back to R1. So again, we may not see the packet loss because these are just some few routers on the network. Just some few routers. But if you have a big network, thousands or 10,000s of routers, it will take time for that route to be propagated. So when I now stop this ping and display the IP routing table, you see that now we have 10.10.10.1 as the next hop. So it has been advertised to this router. But now we need to activate fast reroute on this router so that we have the backup path also installed in the ISIS routing table. And whenever there is an issue, the switchover should be much quicker as opposed to how it's happening right now. So I will enable this route. I will enable this port and do shutdown. Again, when you go back to R1, you expect that it will take some time for that route to be, for the network to converge again and select 20.20.20 as the next hop, because that is the shortest path. So normally it will take some time. You see now it has changed to 20.20.20.20.1 as the next hop. So for us to enable fast reroute, it's very easy and very straightforward. Again, let me change this step. I had not changed the heading, the step detail. So this is configure ISFRR, the fast reroute. So for us to activate ISIS fast reroute, again, we are enabling fast reroute in the ISIS process, and we are allowing ISIS to install another route, but that route should be loop free. So that route should not be causing any loop in the network. That's why we are calling it the loop free. And it's level 2. So remember, we are running level 2. So we need to enable this router to use fast reroute to install an alternate route that is loop free. So this is very straightforward. You just need to run these two commands, FRR, which stands for fast reroute, and then you are allowing the router to install a loop free alternate or a backup path that is not looping, that is loop free, in so that if you allow it to install a route that has a loop, you see you are having issues in the network. So you need to ensure that the backup path is loop free. So these are the commands that you need to use. So for R1, and again, when you're enabling fast reroute, it's always a good practice to enable on all the routers, not just one router. You enable it on all the routers in the network. So I'll do the same for R2, and I'll just use the similar commands given that they are not changing. So I'll do loop free configurations on R1, do it on R3. On R4, we need to do the same. On R5, we do the same. So now, after enabling fast reroute, if I go on this router and now I run the command display IP routing table, display ISIS route 3.3.3.3.3 verbos, you can see that we have this route, and this route has been indicated as the backup. So fast reroute has enabled us to install a backup route in the routing table, and whenever there is an issue with the primary path, the traffic will switch quickly to the traffic will reroute quickly to the backup path that is available in the routing table. We won't wait for the network to converge. We've saved some time. We don't have to wait until the last minute after the network has, again, this is the process. When there is a fault, we need to detect the fault. We need to update the LSPs. We need to flood the LSPs to our neighbors. We need to calculate the routes, and then we need to install the routes in our forwarding information base, and then we can now use those routes to forward the traffic. So we won't wait for all this. We have the backup path. We will switch the traffic to the backup path immediately. So when I again demonstrate that when we shut down the primary path, so I will do again display IP routing table. That is the case when I do interface gig 0/0/1 shut down. On R1, you see that it has already chosen the backup path. So it was very quick. You remember here, we had to wait for some time for it to choose the backup path. But now that we have enabled fast reroute and it has a backup path in the routing table, it's very easy to switch over the traffic. It's very quick. Whenever there is a fault in the network, switch over the traffic to the backup path that is already available in our ISIS routing table. And you can see that it was clearly indicated that it's the backup path. So it's very quick, and it will help to ensure that the network is robust. It's able to handle any challenges like node failure, link failure. Whenever there are power issue, fiber cuts, we can always quickly switch traffic, and it will help to ensure that customers' services are not impacted, or we have minimal disruption to the services. So that is it for the ISIS fast reroute. I hope you've understood how to implement fast reroute, and again understood the reasons why we need fast reroute on this network or on our networks. So thank you so much for watching this session, and I hope to see you in the next episode. Bye.